So this video is for physics, chapter 2, lesson 2, our second lesson on acceleration. And this one gets a little tricky, so I wanted to do a video instead of just putting a picture of my notes. So we have a situation here where our friend Dusty the Camel says, if you can keep track of position, initial velocity, final velocity, acceleration, and time, you will know everything about motion. Now you might think back and go, oh, hold on a second there. We took delta t and we said we can just kind of turn that into t because initial time we'll assume is always 0. Well, I'm doing the same thing now with x. For simplicity, I'm saying let's assume the initial x is always 0. That means final x minus 0 will just be x. So that just simplifies our situation. What we ultimately end up with are what are known as the 4 equations of motion. And this is critical. This is the first really important thing so far in our class. Notice it has a note. We're assuming constant acceleration. I'll get into where these come from a little more later. But right now, you can think of this one as the definition of acceleration, because acceleration is change in velocity over time. If you solve for VF, you will get that equation. This is called the Swiss Army equation, because like a Swiss Army knife, it's useful for many things. If you're doing a problem and you don't know which one to do, try the Swiss Army. This is called the no T because there's no T, and the no A because there's no A. Now I mentioned you don't have to memorize these. I will provide them on quizzes, and you will get to write them on something for your exams, but you do need to be able to use them, and that's what the rest of this lesson is about. Okay. A recommendation is to use this problem-solving method. It will not only help you understand what you're doing, but it will help me give you more points if something goes wrong. So first, draw a picture. It helps you visually, gives you a reference point. Then write down what you know and what you don't know. So for example, you might know that x is 20 meters, that your initial velocity is 0, your final is 50. You don't know acceleration, you don't know time. That's a good way to get organized. It's like in math class when they say write down all your variables. Then pick which equation you want to use. You can choose the equation based on what you don't know, or what you don't want, or what you don't need. And it's a funny little triple negative situation. And I'll show how to do that. Then, a lot of times you plug your numbers in and then you calculate the answer, but it's possible that the best way to do it is if you can pick your equation and do the algebra first and then plug in your numbers. It's a lot cleaner if you can do that. Either will work though. At the end, make sure you check sig figs, check your units, and do a sanity check. See if your answer makes any sense. That will often solve problems that arise. First example. All right, Justin says his Toyota is fast. It accelerates at this rate. How far does it go while accelerating from 0 to 30? All right, so first I drew a picture. That's step 1. So I've got it at 0 here. And then at 30 here. I just wrote the acceleration in the middle to make it easy. And then if I list what I know and I don't know position or displacement. And I don't know the time, but notice the problem doesn't talk about time ever. It doesn't ask about time. It doesn't tell about time. So just ignore that one. And that often will help you figure out which equation to use, because since we don't want t, if you go back up here, it's a good chance it will be the no t equation that we need. And so I grab the no t equation here. I know I want x, and so now I do algebra to solve for x. I start by subtracting vi squared from both sides, which gives me this. I then divide both sides by 2a, and that gives me vf squared minus vi squared divided by 2a equals x. And then plug everything in. Here's my final velocity, initial velocity. A lot of students don't bother putting that because it mathematically doesn't do anything, but I recommend that you do put it just to show that you didn't miss it. All over 2a. You do the math. You get this in your calculator. If you analyze your units, it makes sense because your seconds squared cancels and your meters squared cancels with just the 1 meter, leaving a single meter behind, so that makes sense. You do sig figs. If you go back to the original problem, we had 2 and 2, so the answer should have 2, so I round this to 71 meters. Next problem. A pickle's dropped from a bridge. Why you drop a pickle, I don't know, but hey, somebody probably has done it. And how far does it fall if it takes 1.5 seconds to hit the ground? So this time I drew my picture. I didn't really know anything about velocities, except I do know that VI at the beginning is 0, so I could have put that in my drawing. And we're looking for x. So x is a question mark, initial velocity is 0. We don't know the final velocity, we don't care, so that's why I just crossed it out. Now acceleration is due to gravity, which is 9.80 meters per second squared. Whether to make this positive or negative actually becomes quite a bit of a problem. Traditionally, when gravity is acting on something, it is negative. And when something is being accelerated away from the planet, it is positive. However, that's not always the case. So notice my note here. It depends on the problem. So make sure you do a sanity check. Do what makes sense and then check your answer to make sure it works. Because if your answer doesn't make sense, there's a good chance you put the wrong sign. Also, paying attention to what the problem says. If the problem defines down a certain way or up a certain way, go with what they say. But otherwise, a good way to start is to let gravity be negative. And they said that the time was 1.5 seconds. So in this case, we need the equation that doesn't have VF. Going back up here, the equation that doesn't have VF is the Swiss Army equation. It's also the one that you want to guess if you don't know what to do. Back here, take the Swiss Army equation like I have here. We want to know how far it falls, so fortunately, it's already in the format we want. We want x. One thing that often happens with the Swiss Army equation is the initial velocity is often 0, so that ends up making this whole thing right here 0, so that's nice. That happened there, and then 1/2 acceleration t squared. Do your math. You're left with negative 11 meters. And the negative just means that it went downwards. You could also say 11 meters down instead of negative 11, and those both work. But try to be consistent with how I do it. However, I'm usually pretty forgiving in this case, especially at the beginning. All right, one more. Car slows from 22 meters per second to 3 with a constant acceleration of negative 2.1. And the negative makes sense in this case because it's slowing. If it was speeding up, it would be a positive acceleration. How long or time does it require? So I've got my vehicle moving at 22 meters per second. Now it's moving 3. I tried to show that in my drawing here with the ridiculous cartoon thing. And here's my acceleration. This problem doesn't talk about x, it doesn't care about x, so we don't want x. It turns out the proper equation is this one here, which is the definition of acceleration. Then we're solving for time. So subtract the VI, then divide by the A, and you get this equation. I plugged in my final velocity, my initial velocity, my acceleration. You end up getting a negative both on the top of the fraction and the bottom of the fraction, which results in a positive answer. Do sig figs in units, and you get 9 seconds. Now, if in this case you weren't careful in your math and you ended up getting a time of negative 9 seconds, you know something's wrong. Because in our case, time must always go forward. So if you ever get a negative time, you know something's wrong. That one really stands out. The rest, you just have to pay attention depending on how the problem is worded. And that should do it. If you need help, one thing I could recommend you would do is take each of these 3 problems, write out the problem, write out the question on a blank sheet of paper, and try it on your own. If you need help, look at the notes. Otherwise, finish it and check it. You might have to redo some of the problems a couple times, but if you can figure out how to do these 3 really cleanly, any new problem shouldn't be an issue. You'll have the steps and the tools to solve.